It's a wall of water taller than the Eiffel Tower. It's a wall of water taller than the Eiffel Tower. A wave half a kilometer high, racing toward the shore. This is the image that fills our nightmares and blockbuster movies. It is a vision of total destruction, a force of nature so vast it seems unstoppable, capable of wiping entire cities off the map in a single, terrifying moment. Many people hear stories about these so-called mega-tsunamis and they wonder. They ask a simple but very important question. Could a 500-meter tsunami actually happen in our world? Is this something we really need to worry about? The idea itself is so big, so scary, that it can be hard to separate the facts from the fear. Today, we are going to look at this question with clear eyes. We will use science to understand the truth. We will not use complicated jargon or confusing equations. Instead, we will use plain language and real examples from our planet's history. We will investigate the causes of tsunamis, from the bottom of the ocean floor to the far reaches of space. Let's start with the basics. What are we actually talking about when we use the phrase 500-meter tsunami? It sounds simple, but the meaning can get mixed up. Most people imagine a single colossal wave, 500 meters tall in the open ocean, a moving mountain of water. But scientists usually mean something different. They often refer to run-up height. Run-up height, the maximum vertical height the water reaches on land, measured from sea level. Imagine the ocean calm. Now a tsunami arrives and the water surges inland. Surging water climbs up hillsides, climbs up cliffs, climbs up buildings. The highest point the water touches on land, that's run-up. A 500-meter run-up means the water reached 500 meters elevation uphill. That is not the same as a 500-meter tall wave in the open sea. Coastline shape can amplify run-up. Steepness of hills can amplify run-up. Narrowness of a bay can amplify run-up. Think. Splash into a wide, flat pan. It spreads and stays low. Now splash into a narrow V-shaped funnel. It shoots way higher. Coastlines can act like that funnel. To understand if a 500-meter wave is possible, we first need to understand where tsunamis come from. A tsunami is not like a normal wind-driven wave you see at the beach. Those waves are just on the surface. A tsunami is a displacement of the entire column of water, from the seafloor to the surface. It is a series of incredibly long waves caused by a sudden, massive push on the water. This push requires an enormous amount of energy. There are 4 main ways our planet, or the cosmos, can deliver such a powerful jolt to the ocean. The most common cause of tsunamis is underwater earthquakes. When 2 of the Earth's tectonic plates get stuck, pressure builds. When they finally slip, one plate can thrust upward, lifting the entire ocean above it. This happened in the 2004 Indian Ocean earthquake and the 2011 Tohoku earthquake in Japan. These events created devastating tsunamis that traveled across entire oceans. However, even these immensely powerful earthquakes produced waves with run-up heights in the tens of meters. Typically 10 to 40 meters, not hundreds. The sheer scale of the seafloor movement required for a 500-meter ocean-wide wave from an earthquake is almost unimaginable. Another major cause is a large-scale landslide. This can happen when a huge chunk of rock, ice, or sediment suddenly slides from a mountainside into a body of water, like a bay or a lake. This is like dropping a giant stone into a bathtub. The splash can be incredibly high, right next to where the stone fell. This is a very effective way to create an extremely high wave in a localized, contained area. We have a perfect and terrifying real-world example of this, which we will explore in detail next. Has a 500-meter wave ever happened? The answer is a shocking yes. It happened on the night of July 9, 1958, in a remote place called Lituya Bay in Alaska. On that night, a powerful magnitude 7.8 earthquake struck along a nearby fault line. The shaking was so violent that it dislodged an enormous section of a mountainside at the head of the bay. An estimated 30 million cubic meters, of rock and ice. A mass weighing about 90 million tons plummeted from a height of several hundred meters directly into the water below. The effect was instantaneous and catastrophic. This single event, this colossal splash in a confined body of water, generated the tallest wave ever recorded by modern science. The initial wave was so powerful that it surged up the opposite side of the inlet, scouring away every single tree and all the soil from the hillside to a maximum height of 1,720 feet. That is 524 meters. Let that sink in. A wave washed up a mountainside to a height taller than the Empire State Building. The evidence is still clearly visible today. You can see the sharp line on the hillsides where the thick, old-growth forest ends and the much younger, recovering vegetation begins. It is a permanent scar on the landscape. This event proves that the physics to create a 500-meter run-up are possible. However, Lituya Bay is also the perfect example of a local mega-tsunami. The bay is a narrow, T-shaped fjord, about 14 kilometers long and only 3 kilometers wide at its widest point. The landslide occurred at the very back of this long, narrow channel. The immense energy of the splash was trapped and funneled by the steep walls of the fjord. This is what allowed the wave to reach such an incredible height on the surrounding slopes. It was a unique combination of a massive landslide and the perfect geographic container to amplify its effect. But what happened outside the bay? This is the crucial part of the story. While the wave was over 500 meters high inside the fjord, it had to pass over a shallow sandbar at the mouth of the bay to enter the open Pacific Ocean. By the time it did, the wave had lost almost all of its focused energy and incredible height. Out in the Gulf of Alaska, ships in the area barely noticed a ripple. The tallest wave in recorded history was a purely local phenomenon. It confirms that, yes, a 500-meter run-up can happen, but it also shows that such an event does not necessarily pose a threat to the wider world. Beyond the proven case of Lituya Bay, the conversation about 500-meter tsunamis often turns to more speculative and frightening scenarios. The collapse of an island volcano, a direct hit from an asteroid. For a time, one of the most talked about theories involved the Cumbre Vieja volcano on La Palma in the Canary Islands. Early studies suggested that a future eruption could cause the volcano's western flank to collapse into the Atlantic Ocean, potentially triggering a mega-tsunami that could cross the ocean and devastate the east coast of the United States, with waves hundreds of meters high. This idea generated terrifying headlines and became a staple of disaster documentaries. However, as more scientists studied the problem, a different picture emerged. The scientific consensus has now shifted significantly. Most experts agree that a single, catastrophic collapse of the entire flank at once is extremely unlikely. Instead, a collapse would probably happen in smaller, separate stages over a longer period. This would create a series of smaller tsunamis, not one single monster wave. Sophisticated modeling shows the wave energy would spread out and dissipate across the Atlantic. The resulting wave hitting the U.S. coast would likely be a few meters high, not hundreds. What about an asteroid? This is the ultimate wild card. The impact of a large asteroid, say, one a few kilometers in diameter, hitting an ocean would release more energy than all the nuclear weapons on Earth combined. The initial splash could indeed create a wave thousands of meters high near the impact site. It would undoubtedly cause an ocean-wide tsunami of catastrophic proportions. The impact that wiped out the dinosaurs 66 million years ago, for example, is thought to have created tsunamis with run-up heights of hundreds of meters all around the Gulf of Mexico. But here, we must talk about probability. An impact of that scale is an exceptionally rare event, happening on timescales of millions of years. NASA and other space agencies constantly track near-Earth objects, and there are no known asteroids of that size on a collision course with Earth in the foreseeable future. Smaller impacts are more common, but they lack the energy to create an ocean-spanning mega-tsunami. So, while an asteroid is the one cause that could theoretically generate a 500-meter tsunami across an ocean, the chances of it happening in our lifetime, or even in many thousands of years, are infinitesimally small. Why is it that a wave that starts out as a 500-meter high monster in one spot doesn't stay that tall as it travels? The answer lies in basic physics, conservation of energy and radial spreading. As the wavefront expands, its energy is distributed over a larger area, and its height must decrease. Friction with the seafloor and complex underwater terrain further dissipate and scatter energy. So, after looking at the science, the history, and the physics, what is our final verdict? Can a 500-meter tsunami happen? The answer is a clear and qualified yes. But yes, a wave causing a 500-meter run-up has happened before, as proven by Lituya Bay. This can occur from a massive landslide into a geographically confined body of water, like a narrow fjord. The risk from this type of event is real, but extremely localized. It is a threat to a specific bay, not to an entire continent. The chance of an ocean-wide tsunami that remains 500 meters high across thousands of kilometers is, for all practical purposes, zero. The energy required is simply too vast, and the laws of physics that govern how waves spread out and dissipate energy make it a virtual impossibility. The scenarios that could theoretically cause it, like a major asteroid impact, are so rare that they fall outside the realm of practical risk assessment for our daily lives. Forget the 500-meter movie monster. Prepare for the real, dangerous, and survivable waves that our planet can produce. What we should be concerned with is the very real and proven danger of tsunamis in the 10 to 40-meter range, generated by great undersea earthquakes. These are the waves that have caused immense devastation in our recent history. Therefore, our focus should not be on preparing for an impossible mega-tsunami, but on respecting the real tsunami threat. This means being prepared. If you live in or visit a coastal area, especially near the Pacific Ocean's Ring of Fire, you must know the warning signs. A very strong earthquake that makes it hard to stand is your first and most urgent signal. A sudden and unusual rise or fall in the sea level is another critical sign. Do not wait for official sirens or alerts. If you experience these signs, your immediate priority is to move to high ground or far inland as quickly as possible. Know your community's evacuation routes. Heed all official tsunami warnings and orders to evacuate. These systems are in place to save lives from the real tsunamis that can and do happen. We have the scientific tools to detect major earthquake-driven tsunamis and provide warnings hours in advance. By understanding the real risk and knowing the simple steps to safety, we can protect ourselves and our families from the true power of the ocean. Forget the 500-meter movie monster. Prepare for the real, dangerous, and survivable waves that our planet can produce. Be aware, not afraid. Prepare for the probable, not the impossible. The power of the ocean is immense, and it deserves our deepest respect. But that respect should be built on solid science, not sensational headlines. We promise you a clear, honest answer based on what scientists know today. Understand local run-up versus ocean-wide height. Know the signs, have a plan. If this helped, share it with someone who lives near the coast. Stay curious, stay prepared, and stay safe.